Today we are going to go through the exam 3 review that's posted on Beachboard. So if you don't have the data pulled up or if you don't have like the review pulled up, the answer sheet is really kind of the main focus of what we're going through. I gave you guys the data sets if you want to work through organizing data and that type of stuff for practice. I won't be running any tests in SPSS today. What I actually have pulled up is the outputs from the tests that I ran. Originally, I was going to run the tests in SPSS, and then I was like, ugh, that might take too much time. And I wanted to give more time to like for questions and that type of thing. So we'll be working off of outputs today. I posted these or I ended up posting them on Beachboard earlier than I thought I was going to. So you can always reference these if you want to. Also kind of good if you're wanting to practice running through your procedures, then you can kind of use the outputs to cross-check if you set up your test correctly. There's a study guide posted that pretty much summarizes kind of the main things that you'll want to know for the test, has any relevant calculations, which are pretty much related to the omega squared effect sizes for one-way ANOVAs, and then the different calculation parts of our ANOVA tables, again, for one-way ANOVAs specifically. So I think you should have everything you need to get a good studying in. Are there any questions before we start?
Is there a test on Monday?
Oh, yeah. So in the syllabus, it's listed as a Wednesday exam.
Okay. This
Yeah.
Wednesday?
Not this Wednesday. It'll be next Wednesday on the 8th.
Okay, perfect.
That's the date. Yeah. The time constraints will still be the same. So, and the general format will still be the same. So you'll have a set of multiple choice questions that are more or less like targeting like terminology. Some of them might be associated with some of like the other output questions that you have. They'll be mixed in, but there will be some multiple choice questions, mostly short answer type questions. What else? Probably it'll be about the same length as your previous exams. I haven't finalized all of the questions yet because the order of this exam is different, or the content that's in this exam is different than previous semesters. So I still have to finish writing it, but I'll send an email out probably Saturday or Sunday. I'm shooting for Saturday with any like special topics or kind of like how the test is going to be organized so that you guys know what to expect. Oh, is there anything else? I can't think of anything else right now, but if you do have like a conflict and Wednesday doesn't work for you, then you can email me and set up a different day to take the exam. I originally had Wednesday on the syllabus because we were supposed to have an activity this week, and that would have given me time to grade the activity before you took the exam. So I don't know. It was on the syllabus as Wednesday. I figured most people wouldn't mind having the extra couple days to study. So I just kept it on Wednesday. But yeah, if it doesn't work, just email me and I can reset the availability so that it opens on the day you can take it. Okay.
So I have a quick question.
Yeah.
So we don't have activity 10 or we do have activity 10? No? Okay.
No activity 10. Yeah. So basically everybody gets a free activity. I think I already updated those points on oh no. I think I already updated those points on Beachboard. So it should have gone in, I think it was like set out of 10 points. So everyone should have 100% on that. But yeah, the poll, most people said like they would have preferred to turn in like a rough draft of their final project. So if you want to do a rough draft, it's completely optional to submit something. But I would probably advise submitting like a baby outline. It doesn't even need to be a whole page long. It could just be like, this is the research question we're thinking of. These would be like, this would be our independent and dependent variables. This is the statistical test we would want to run just to see if you're on the right track before you like put your efforts into writing up your full report. And then I can give feedback on that or make things to consider, that type of thing. But yeah, so this is like aside if you decide that you want to do the extra credit review quiz for this week, that's pretty much the only assignment you'll have up until you take exam 3. And then after that, it's just the final project, and then you guys are like free unless you elect to take the final. But we're almost done. So, woo. Okay. Any other questions before we start? Okay. I won't take that. No. So for the review, I've just given you guys one of each type of ANOVAs that we've run for this section. So you'll have a one-way independent and a one-way repeated measures ANOVA. And then you'll have 3 two-way ANOVAs, one independent, one repeated measures, and then one mixed factor ANOVA. So you have one more like round of practice for anything or for any types of these tests. I really want to get rid of this meeting controls thing, but I'm afraid that I'm not going to see chat if I get rid of it completely. So this is troublesome. It's fine. Okay, never mind. All right, we'll start with data set 1. For all of the data sets that I give you guys in this, you'll just assume we have a 95% level of confidence. So all of our alpha levels will be at 0.05, similar to the activities we've done prior to this. And then everything will be a two-tailed test. So all of your null hypotheses will be on par with, again, what we've used in our activities. I have this note and it'll apply to the exam as well. I'm pretty sure I've checked everything, so we shouldn't have any cases where there's not a p-value when there should be one. But if a p-value is not provided in the output, and you would have expected one, just explain why it's not there, and then note your decision on how you're proceeding with the test. If you have a case, which we do have an example in one of these data sets, when you've got the 2 levels of your independent variable and there's a sphericity test in your output, then that's one of those cases where you say no p-value is provided because there's only 2 levels of the independent variable, but we'll assume sphericity is met, type of thing. So you should have some type of justification for every decision you make for all of your assumptions. But those are kind of just like the general things we're going to assume for all of these. We're also assuming that we have a normal distribution of our dependent variables, so we're not testing that for any of these. And we're assuming that we have random sampling of our data. So with that being said, I'm going to type in answers as we go. So if you want to type them in with me, that's cool. For data set 1, our research scenario is that students are doing a project to look at the effects of feet placement on bench press performance. They have gathered 30 individuals to come in and do a 10 RM bench press test. Each participant was randomly assigned to one of 3 foot placement conditions. These consisted of feet shoulder width apart and feet flat on the ground, feet together and flat on the ground, and then feet together and flat on the bench. The results for the 10 RM tests were normalized and reported as a percentage of body weight. So just to give you an idea of what the data look like in Excel, we've got 3 different conditions and then measurements reported as a percentage of body weight for the 10 rep max bench press test. Okay. So for this, what is my independent variable? I'll open the chat box so I can see what you guys are saying. Or you can yell it out if you want to yell it out. Independent variable, anyone? There we go. Yeah, foot placement condition. Okay. All right, foot placement. For all of our ANOVA examples, we're going to argue that our variables are nominal. So that's what I have for our characteristics. We're identifying what the independent variable is, type of data, nominal. Number of levels, I kind of gave you guys that in the description. So we have 3 conditions. And I can't spell. And then the last thing we're noting is if this is a within or between subject factor. So what do you guys think? Yeah, between. Woohoo! Okay, because every single person has been divided, right? They were randomly assigned to one of 3 foot placement conditions. That's kind of the hint for that. Okay, so that means when we're in our data set, what we would have to do, and I'll make this a little bit bigger so I can see what's happening. You would want to make a legend, right? One for each of the foot placement conditions. So you could fill those in there, right? And then when you organize your data, you would have a column for like the foot placement group people were in, and then their 10 RM percent body weight, like weight they were able to lift, right? So then we would say, oh, everybody who had their shoulder width, feet on the ground, we put their data there, and maybe that's condition number 1, right? So then we would just stack all of our data and then copy and paste it into SPSS. So that's how we'd organize that. What's the dependent variable? Kind of already said that. Yeah. So percent body weight is the unit we're measuring. Technically, it's like our 10 RM weight, or the weight that was able to be lifted for 10 reps. And we would say that's ratio data, as most of our examples in this class are. So given that information, what type of ANOVA would we run? One way between, one way independent. Yeah. Okay. And we could deduce this because we have one independent variable that's a between subject factor, right? Our assumptions for this. I can let you guys fill this in. It's pretty much from the lecture notes, but we would have random sampling, normal distribution with no significant outliers for each level of our independent variable. We'll have our characteristics for our dependent and independent variables. So one dependent variable that's ratio or interval data. I see Juan put in it needs 3 levels. Yeah. So we'd have one between subject independent variable, which we've got that has 3 or more levels. If it only had 2 levels, then that would make it a t-test, which we don't have on this exam. And then the assumption that we'd be running in SPSS, I'll type this one out so that we have a reference to it, will be homogeneity of variance. Okay. So rule of thumb for between subject factors or between subject independent variables, you always have to run homogeneity of variance on those. If you have a within subject factor, then you're looking at sphericity. Okay. Homogeneity of variance has a null hypothesis that there are equal variances between the levels of the whatever the between subject factor is. Okay. So I'm kind of keeping this on the general side, but when we interpret our p-values in our actual output, we would want to substitute like our between subject IV for whatever it is in the example. So in this case, it would be foot placement. Okay. Let me pull up the data set one. This is the output. I need to shuffle some things around my screen really quick. That'll work. So this is the output that I got. Our test of homogeneity of variance is kind of the first stop that we make. So this is Levine's test that tells us if we've met our homogeneity of variance assumption or not. So in the output, we can see that our p-value under the based on mean row is 0.938. Okay, so similar to like our activities on the exam, I likely will phrase your questions like this, or they might be like multiple choice, similar to what you've seen in quizzes, where it'll give you like a p-value and an interpretation. You just have to match the p-value and interpretation to whatever is on par with the output results. But in this case, p is equal to 0.0938, which is greater than 0.05. So we can accept our null hypothesis, right? And the interpretation would be that there are equal variances between all levels of foot placement. Doesn't sound super eloquent, but that's the gist of things. Okay, so when we have homogeneity of variance for a one-way independent ANOVA, that indicates that we should look at the ANOVA table. Okay. Whenever we, I think, oh yeah, I did stick it in here. If we ended up violating homogeneity of variance where we had a p-value less than 0.05, that's when we go to the Welch's test and we would read the p-value in the Welch's test. Recall that the p-value in the Welch's test as well as the regular ANOVA table are interpreted the same way, but they won't always be the same value. So whenever I ask you guys like, oh, report the p-value for the ANOVA, this and for any of the repeated measures ANOVAs, because the p-values are not guaranteed to be the same based on the type of adjustment that's been doled out on the test. If you do not have the exact p-value that like as it is shown in SPSS, then it will be marked wrong just because there's so much variation. So double check that you're typing those out correctly. But for this example, P for our ANOVA is equal to 0.012, which is less than 0.05. So we can reject our null. Okay. And then ANOVAs are looking at if we have significant differences between the means of our groups. So in this case, we're looking at if foot placement has an effect on bench press performance or how much a person can lift in a 10 rep max test. So a way that I could report or interpret that p-value is that foot placement has a significant, there we go, effect on, I'm just going to write bench press performance because I feel like that's easier than trying to phrase the 10 RM stuff. Okay. Is there ever a time where both tables reject the null? Yes. That actually, it's not the case for this example, but let's say that this p-value was less than 0.05, and then we looked at Welch's test and ended up with a p-value also less than 0.05. That's a possibility. Because Welch's test is only used when you violated homogeneity of variance. So what happens is an adjustment is made to the degrees of freedom in your example so that the variances equal out. But the p-value for the Welch's test would be interpreted the same way as if we were interpreting this p-value in the ANOVA table. So for example, if we had violated homogeneity of variance for this example, and we looked at Welch's p-value, we would say p is equal to 0.011, which indicates that foot placement has a significant effect on bench press performance. So interpretation is the same as what we just wrote down. Yeah. Did that answer your question? Cool. Just making sure. Okay. All right, so since we had a significant main effect, we would want to look at our post hoc tests, which for a one-way independent ANOVA is Tukey's post hoc tests. Since we had equal variances, we'll use the Tukey p-values over here. If we had violated homogeneity of variance and we used the Welch's test for our p-value, and this was significant, then we would use the Games-Howell post hocs. So try to keep your pathways straight. But I've highlighted already in here what our significant pairs are, which it seems is just shoulder width versus our feet together and on the bench. So I would write this as like bench press performance was significantly different between the feet, we'll say shoulder width apart, and feet together on bench conditions. Sure. And we're saying this one is significant because our p-value was less than 0.05. Right? It was listed as 0.009. All of the other p-values, oh, I missed one actually. Oh, never mind. That's in the Games-Howell. All of the other p-values in our possible pairs are larger than 0.05, so they are not significant. I just realized I spelled that wrong. Okay. You could also write this as like all pairs are not significant except, and then write the one that is significant. So multiple ways you could report that. The effect size that we use for um, a one-way independent ANOVA is our omega squared. So if this was one of the cases where you had to set up your test in SPSS and you chose to report or you chose the box that's like estimates of effect size in the options box when you set up the test, under the point estimate column in the omega squared fixed effect row, that would be our effect size. I also gave you guys a formula in like previous weeks where you could calculate your effect size based off of components of your ANOVA table. But I mean, we're given this, so I feel like that's an easy way to say it is equal to 0.074. Question for pairwise comparisons in the chat is, could we also write up significant difference part, or the significant different part and of your sentence, then add bullet points for pairs? Yes. So that in that respect, you could say like there are significant differences between, and then just write the pair, like feet shoulder width apart, feet together. That format is especially useful if you have a lot of pairs. But yes, you could do that. Question to you guys: what is this, a small, a large, or a medium effect size? Or maybe it's somewhere in between. Yeah. Large, medium. So the criteria for this, remember, is if you have an omega squared and partial eta squared, the values are interpreted similarly, right? So if you have 0.01 or something close to 0.01, that's small. If it's about 0.06, it's more medium. 0.14 and above is considered large. So I would say this is probably closer to medium. So we'll just say medium effect size. And this is the effect size for the differences between foot placement conditions. I'm not going to write that for this one just because we don't have all of the extra stuff. If you say large, no, I would still probably say it's okay because it's in between. And the same will go for the exam. So if there's a value that's like, it could be argued either way, I probably will give it both ways, because that's more of a subjective evaluation. Any questions on this first one? Okay. All right. Well, then I will minimize this one. Pull up data set number 2. So for this one, we have a study aimed to evaluate the effects of respiratory muscle training on pulmonary function in competitive triathletes and marathon runners. 12 participants who had a mean weekly aerobic training time of 7.5 hours per week of swimming, cycling, or running were included in the study. Subjects were first given a placebo or a control device that allowed no greater than 10% resistance on both inspired and expired air. 30 maximal inhalation exhalation trials were performed on the device 2 times per week for 4 weeks. Forced vital capacity, or FVC as we will abbreviate it, was measured in liters before and after the 4-week training period to assess any changes in pulmonary function. So this training period was followed by a 2-week rest period, after which subjects were given a second resistance device that provided 30% resistance on both inspired and expired air. And then the same 4-week protocol was performed for the pulmonary resistance condition with the same pre and post training measurements. In order to better isolate the effects of each training device, subjects were instructed to continue their regular exercise regimens for both 4-week training periods as well as during the rest period. So, same questions as before. What do you think the independent variable or independent variables are? And so you have reference. This is what the data look like, if that helps you make any decisions. I see one type of training. That helps. I'll start typing. And then if anybody feels inspired by another independent variable, feel free to add it to the chat. I think Juan said type of training. I'm going to put the device that was used because it's either like the placebo device or the resistance. So that's the wording I'm going to use. Type of training would also be acceptable. But device is what I used in the output, so that'll make more sense referencing stuff. But yes, it is nominal. And we've got 2 levels, right? Placebo and resistance. And then this would be considered a within subject factor because people are using both the placebo device as well as the resistance device. Okay, so they've been used for the same condition. Sylvia has skipped to this other question. For the dependent variable. Nope, you're good. Okay. Dependent variable would be the forced vital capacity, which is considered ratio data. Has anyone decided what the other independent variable is? Butter's trying to join the chat today. So.
I think Juan said it. Chat before mine.
Time of measurement. There we go. Yes. So we'll put time. That's kind of just to see if the program worked. Yeah, that one would also be nominal. We'd have 2 levels because it's a pre and post measurement. And because it's a pre and post measurement, each person gets measured more than one time. Okay. So given that information, what type of test would we run? See a 1 vote for one-way repeated measures. Does anybody concur? Vote for something else. How many independent variables are there? Yeah, there's 2. So this one would be a 2-way repeated measures. We could also write as a 2x2 repeated measure, a 2-way within, 2x2 within. There's different ways that could work. We're going to have similar assumptions, right, as our previous example in terms of random sampling, normal distribution, that type of thing. Differences are going to be that we've got 2 within subject independent variables that have at least 2 levels each. And then I'm going to do the same thing as the last one, where I'll put the assumption that's run in SPSS. Does anybody know what it's called? We have within subject factors, we look at not Levine's test. There we go, sphericity, right? Which is going to be tested using Machli's test. So for this one, our null is that, or generally speaking, the variances of the differences between all levels of the I cannot spell. There we go. Within subject factor, or within subject independent variable, are relatively equal. So kind of similar to homogeneity of variance, but the main difference is the differences. That's not confusing. I'm sorry. So homogeneity of variance looks at the variance of each group and then says, are these variances equal to each other? For sphericity, we say, what are the variances for each group? And then what are the differences between each of those variances? So if we had 3 groups, we'd look at the difference between the variances for groups A and B, groups B and C, and groups A and C. Okay. This is the reason why sphericity won't give us a p-value if we only have 2 levels, because the difference between the variances of 2 levels is just one difference, and then we're not able to see if differences are relatively equal or not. Okay, so sphericity, in order to get a p-value, you need at least 3 levels. So that means for this particular example, we shouldn't get any p-values for sphericity because we only have 2 levels of each independent variable. Okay. So that's kind of jumping ahead to this question, but let's see this one here, just to show you what to mean. If we ran a repeated measures test, right, you could see in here no p-values. So for our answer, better. I know you're trying, but it's not a good time right now. Okay. We would say something like no p-values are provided for device program for the interaction because there are only 2 levels of or 2 levels for each independent variable. That'll work. Okay. So if you get something like this on your exam, you would just say no p-value because there's 2 levels, and then you want to put what your decision is. So we've said if we only have 2 levels, we'll assume sphericity. Okay. How many main effects should I have for a 2-way ANOVA? Three. Yeah. All right. So we should have 1 p-value for the device that was used. So I'm just going to type device. We should also have a p-value for the time at which we measured our force vital capacity, right? So that's difference between pre and post measurements. And then we'll also have the interaction effect between device in time. Okay. So if we consult our test of within subjects effects table, we can see device, time, and device times time, which is our interaction. I have to move. I don't know where to put this. Okay. I periodically cannot see the chat box. But for device, we have a p-value under sphericity assumed that we've got 0.567. Okay. So we'll say p is equal to 0.567, which is greater than 0.05. So would you guys say we accept or reject the null hypothesis? Accept. Yeah. Okay. So if we accept the null, we would end up saying that like the type of device used has, device, has no significant effect on FVC, or you could put pulmonary function as well. And this is regardless of when FVC is measured. Okay, so that would be like if we took all of our forced vital capacity measurements, both pre and post, we clumped them together for each device and then just compared the mean of forced vital capacity. In this regard, it's saying if we mush all of our FVC measurements together, there's no difference between our devices. Okay. P-value for time is listed as less than 0.001. Okay, so we can write that. That's less than 0.05. So in this case, we would reject the null. And then we would say that there is a significant difference between pre and post intervention measurements. Significant. Between. I like between. Okay, and this would be differences between pre and post measurements, regardless of the device used. Okay, so in this case, we would say all of our pre-measurements, both placebo and resistance devices combined, and then all of our post measurements, both devices combined, take two means, compare them to each other, and this is what we get. Okay. The p-value for our interaction is 0.012. So we can report that one. Also less than 0.05. So we would reject the null and say that there is a significant interaction effect between the type of device used and when FVC is measured. That would be getting at like the time component. So based on these p-values, which pairwise comparisons would we want to look at for this example? Yeah, time and interaction, right? So this is kind of where the flow charts come in handy, right? We looked at our assumptions, found out we met sphericity, looked at the sphericity assumed column for all of our p-values for our main effects, figure out which ones are significant, and then the ones that are significant are the ones that you end up looking at post hocs for. So in this case, because device was not significant, that's kind of where that analysis is going to stop. But we do need to look at pairwise comparisons for time. And then there will be two sets of pairwise comparisons for the interaction. One will look at differences between devices within each time point. And then our other set will look at differences between time points within each device. Okay. This is like how I like to go about taking notes on stuff. So I just write out which ones were significant. And then over here, you'll see I already deleted the first set of pairwise comparisons. That's why it starts at 2, 3, and 4, because I was like, I don't need it. So I tossed out the window. But under time, if we look at our pairwise comparisons, this should be redundant with our main ANOVA table because we only had 2 levels of our independent variable, right? Pre and post. Basically, this pairwise comparisons test is going to do the exact same thing that our ANOVA did, because it's just saying what are the differences between these 2 means when we don't account for the device that was used. So our significant pair will be that pre and post intervention FVC are significantly different from each other, or how do I write that? Yeah, I'll just write it this way. I don't want to hold it though. That'll be bothersome to me. FVC was significantly different between pre and post intervention measurements. And then you can tag on the extra part regardless of the training device that was used. Juan asked a question, can we say that there was a significant difference for all pairs? You could, but there's only one pair, right? Because remember this second one here is redundant with the first. So pre and post is the same thing as post and pre. Yeah, the only difference is the order that the mean difference is calculated. So you'll see like one of these is positive, one is negative, but they're both the same mean difference value. Yeah. So if there's only 2, then I would just list the pair. Probably easier. But either way, it would be correct. All right. If we look at our first set of pairwise comparisons that look at the differences between our devices within each pre and post time point, our p-values reflect that there are no significant pairs. Okay, so because I was only asking to identify significant pairs, I'm actually going to take that bullet point out because I don't need it now. And then for device and time, my second set, where we're looking at differences between time points within each device, we can see there are differences between both pre and post measurements for both of our conditions. So we could write that as pre and post intervention FVC measurements. well, I'll use past tense, were significantly different. For both the placebo and resistance devices. You can put the p-values, you don't have to put the p-values. As long as you have the right pairs within the right conditions listed, that would be fine. And then our effect sizes for a two-way ANOVA, we want to look at the partial eta squared. I've noted that I want effect sizes for the significant main effects and or interaction pairs if applicable. So in this case, that would be applicable since we had an interaction effect. But I do the same thing as I did for the previous question where I list out which effect sizes I will need. And I'm gonna make this red. Where do I find the effect size for time? Time a main effect or an interaction effect? We will end up using the multivariate table for something. Yeah. So we use the test of within subjects effects table for the effect sizes for our independent variable main effects. For the interaction effects, that's when we look at the multivariate table. So we have both answers in there. I'll go back to the test of within subjects effects table. And I highlighted the effect sizes for both device and time, just so if you guys wanted to reference where they would be located. Because device was not significant, I won't report that one, but we will report the effect size for time. So we have 0.842, which is larger than 0.14. That's our criteria for a large effect size. So we would just say that we've got a large effect size for the differences between pre and post intervention measurements. And then Juan had indicated that for the interaction effect, we would want to look at the multivariate table. I skipped straight to the second set of pairwise comparisons, because in the first set of pairwise comparisons, we didn't have any significant pairs. But in the second set of pairwise comparisons, we did. And we had a significant pair in both the placebo and the resistance groups. So that's why I've highlighted 2 effect sizes in our multivariate table. And this would tell us both of these are larger than 0.14. So they're both large. I could put there are large effect sizes for the differences between pre and post measurements. Measurements, there we go. For both the placebo device And my partial eta squared for the placebo device was 0.490. And resistance device, partial eta squared of 0.835. Cool. Questions on this one?